And maybe it would help, for example, if we should we just maybe use a quick toy example that is probably pretty close to things that both of us have done, where we both have an academic version of it and sort of a more industrial production version of it. So, for example, say that you're trying to monitor a number of entities where, say you have a number of, I'm trying to decide how explicit I'm going to go on this, but essentially, say you have essentially a number of sensors, for example, and each of those sensor is of a unique value. So each of those sensor might be a customer, and that customer is generating a series of values. I'm not saying it's like a super continuous time series, but they have multiple values over time. And so effectively what you might be doing in the academic setting is saying, okay, when we try to detect these anomalous, which customers are anomalous, what we first might do is say, okay, well, let's develop a customer specific distribution for each of those. So essentially we go from having a number of data points to now we have a number of distributions, one for each customer. Mm-hmm. And then that brings up the new technical question. Well, we're calculating the distribution, but how do we know our distribution is good? Because obviously we're automating that statistical inference process. And so we say, okay, well, how do we regularize, or how do we improve that so that it's more precise and a better descriptor, such that we have this down the line view of detecting anomalies? And so that might bring in the factors like, well, maybe we want to put in Bayesian priors, and we can put in some priors on that. And you can see where this is starting to go. It's like, but then again, what about other features? So that you might have for these. So for example, in addition to the raw data itself, you might have extra features for this customer. For example, like their customer size, how many employees they have. So effectively, now we're doing two things. We're turning this into more of a regression type model, or some broadly regressional type model. And the moment it's nonlinear, it's like, well, which nonlinear model do you want to use? Do we want to use a hierarchical model, or do we want to maybe use a Gaussian process so that we can just sort of plop density where we need to? And you can start seeing that it's like, well, okay, say we're going to use this regressional model. What's the length scale of the effect on the customer side? So how rapidly will these change? And our customers with 10, do they change the same amount, or once you get super big, does the rapidity of change as well? So you can see that, and those are very interesting technical questions. Yeah. Like that's the stuff that I love to do. But the fact is, each of those steps adds and adds and adds. And yeah, you can look shiny and smart by doing those things. But the question is, for each of those, you need to create a formalized inference step, and you need to basically curate the data in certain ways and make sure that it's very well controlled. Whereas the other option on the other side is you create a dashboard, and you really just plot that data and give each person a little box, and you can just look at the distribution. And if you want, then you just plot it with respect to this other feature. So effectively, you're just visualizing the effect of the feature. You make a 3D plot, and it pretty much shows everything you'd want. And that doesn't require any of the formalization process that you would for the fancy machine learning or data science work that we all love and sort of really like to see, because it feels good in our guts. Is that an example where effectively on one you can keep pushing that and add technical complexity, which is it is real technical complexity. It's not like you're making up work, but it's
absolutely yeah. I mean that's a great example. I think the important thing to note as well, all the deeper technical challenges that you talk about, all the different ways that we can slice a problem up, like you're given in your example there, those things potentially are really useful things to do as well. You know, like the fractal of stuff, while it is like a bit of an attractor, like people who are maybe more technically inclined to go and navigate that fractal, or at least try to, well, it's not to say that those things aren't useful, because very many of them will be. I think it's just in the hierarchy of needs for a given business problem, there's going to be something like just the visualization that can be done that will then, it just immediately provides value there's no barrier to or it doesn't need to be unlocked by product of this much more technically difficult set of steps that you'd have to take to look at the more intricate aspects of some of the techniques you were referring to there. I think the important thing to remember is, so sometimes people seem quite defeated by this. They think, well, you know, I really want to do all this really fun work. Like I really want to look at the details of how we take a a given method and we dig into the kind of weeds of it and look at the potential optimization techniques we can use, or maybe we spend a lot of time in the kind of model selection world and we try out a new methodology for, I don't know, like some kind of machine learning method. Those things can be really useful. I think it's kind of like being pragmatic about how you ensure that the delivery of the output from like a data science process. And I talk about that when I say the data science process, I mean like the output from the data science team. You have to just being pragmatic that has to be it's a part of the decision making process behind which route you take as well. But certainly, I mean, there's so many problems within all sorts of domains where that kind of technical complexity is not necessarily even like a shiny thing to go and look at and kind of satiate our curiosity. Sometimes those things are barriers to providing a solution. So there will be plenty of scenarios where you'll be dealing with technically very difficult data problems that will require that level of rigor. I think though it's just first of all identifying those well as part of the process of your investigations is a challenge in the first place. But also, like in the example you gave there, just doing some visualization and communicating the challenge of the problem and maybe giving some incremental benefit to the team more widely is definitely something that I think is a much more kind of like repeatable process to take when you're looking at these kinds of problems. And very often what will happen is it might just be, the exploration part is good enough for whatever people are trying to solve in the business more widely. But at the same time, that's not the end of the story. That might turn into something that's then, okay, we have some data exploration process that a data scientist has run here. How do we look at this and make it more robust, and how do we automate this so it's not having to be done ad hoc each time, or what's the potential deeper questions that this analysis opens up as well? Is there other business led kind of questions that we can start to ask based off of that that approach we've taken that maybe wasn't technology driven, but it was certainly problem driven. And I often find from my experience is it opens up more questions as well. What you'll end up, there'll be more interesting questions underneath that first layer that then become available because you've had this to and fro conversation between the data science team and maybe folks who aren't data science specialists, who you're maybe reporting back to, kind of stakeholders in the business more widely. And then it gets really interesting because there's an enablement and kind of like a conversation that happens where you have something that previously wasn't investigated because either the data science team wasn't there, maybe the expertise wasn't available to begin to visualize, even if something as simple as visualizing the data to answer at least the first step of a question. And then maybe if it's a product team you're working with, they then, off the back of that value that's been delivered to them, they go, oh, this is really cool and really neat. We can see X, Y, and Z. So what about questions A, B, and C off the back of the analysis that we've done? And it becomes like a kind of virtuous loop where some really interesting questions can get answered based off of that process working really well, which I think that kind of does get lost if you try and step back and just try and, well, in fact, not step back, but shoot in for the really technically difficult solution to begin with.